This is the third problem from our Exam 2 Extra Transformations practice. So the instructions are still the same. And the transformed function that we're looking at here is 1 minus the absolute value of x plus 1. So starting with the first point, we're working with absolute value here. So our basic function is the absolute value of x function. Okay, let's think about transformations. So as I'm writing the word transformations here, think about how many of them are there, right? So compare the function that you're left with, your g, to the original function. And what you can see is you have two transformations on, you have three transformations. So you have this plus 1, you have this minus, and you have this 1 on the outside. Reflections first is kind of generally how we approach it. There's no reason for that, so if you don't want to do this reflection first, you don't have to. Just be mindful of the order. But I'm going to do the reflection first because that's kind of how we've done it in the past. So the first thing we're doing is this minus sign. That's our reflection. Generally, when you see a minus stuck in front of something, that's a reflection. Good thing to keep in mind. So this is going to be a reflection in the x-axis. And as before, let's go ahead and talk about coordinate analysis as we go. So if we're starting with some random point on the graph of f, let's call it x comma y, reflecting in the x-axis keeps the x-coordinate the same, but you're being flipped over the x-axis, so your y-coordinate is made negative, so or opposite, I should say. So the reflection in the x-axis flips our y-coordinates. Next, we have some shifts. So this plus 1 on the inside, that's going to be a horizontal shift. This 1 on the outside is going to be a vertical. Frankly, doesn't matter which one you want to do first. So let's go ahead and do the vertical shift first. Vertical shift up 1 unit. So again, you're coming off of having finished your reflection. So you're currently at x comma negative y. And then when you shift up, all of the y coordinates increase by 1. So you could write this as negative y plus 1. And it's probably a little bit neater to write it as 1 minus y. So that's how we'll write it in future. Our last transformation is this plus 1 on the inside of the absolute value. That is a shift to the left by 1 unit. So again, we started at x comma negative y plus 1, which I'm writing as 1 minus y. A shift to the left only impacts the x coordinates, and shifting left is going to subtract from our x coordinates. So we end up, the final destination of our original function's point xy is the point x minus 1 comma 1 minus y. So again, you started at xy, and then you wound your way through 3 transformations, and this is where you ended up. Okay? Cool. So now that we've done the basic function, we've listed our transformations, and now we've also listed our coordinate analysis. Let's go ahead and think about the graphs. So first things first, let's sketch our axes. So there's our y-axis. Let's make it nice and vertical. Okay. And then here's our x-axis. All right. Always label your axis. So here's your y-axis. Here's your x-axis, remember. So let's start with the graph of f. Absolute value of x. So again, by now I hope that this is a fairly familiar shape. Remember, absolute value just measures the distance from the origin. So it doesn't count the direction in which you're moving, just the number of steps. So the absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of -1 is also 1. So I'm saying at least 3 points. Here are 3 points. But at least literally means at least. If you need more points, then take more points. The absolute value of 2 is 2. The absolute value of -2 is 2. So you have this V shape, right? You have like this and like this, okay? So then from there, let's figure out the points on the transformed graph using our coordinate analysis. So if we're starting with the points x, y on the graph of f, so let's just list them. We've got -2, 2, we have -1, 1, we have 0, 0, we have 1, 1, and we have 2, 2. So you see, I'm doing it on more than 3 points here. Totally fine. And then where they end up on the graph of G is x minus 1, comma, 1 minus y. So for each of these, I'm going to plug the x coordinate in for x and the y coordinate in for y. So if x is -2, x minus 1 is -3. If y is 2, 1 minus that is -1. If x is -1 and y is 1, then we'll have -2, comma 0. If they're both 0, then x minus 1, 1 minus y will be -1, 1. For 1, 1, we'll have 0, comma 0. And for 2, 2, we'll have 1, comma -1. Okay? So again, for each of these points, I'm plugging x in for x and y in for y. So that is how I get the new points from the original points. All right, so here we go. -2, 2 is at -3, -1. -1, 1 is at -2, 0. 0, 0 goes to -1, 1. 1, 1 goes to the origin. 2, 2 goes to 1, -1. So this is important. You are looking for the same shape, right? We started with a V shape. We should end up with a V shape. But, shifted, reflected, that kind of thing. So if you're getting a shape that is completely different from the one you started with, like something is up with your points someplace. So double check them. Okay, so the blue is the graph of our original function. The green is the graph of our transformed function. You can see that the green graph is identical to the blue graph. It's just been flipped upside down and then shifted to the left and up. And this lines up with the transformations that we detected when we were listing transformations. So that's the third example. Stay tuned.